So, all right, so we are in the 1.3 part 1, discovering cofunctions. Those first couple of questions are yours, but we haven't really done this chart in a little bit, so I was going to go through it with you. Remember, sine, sine is y, cosine is x. Does anyone remember what tangent is? Nice, y over x, good job. So say, for instance, you were looking for the sine of 30 degrees. The sine of 30 degrees can be found by just thinking back to the y-coordinate at 30 degrees. So the y-coordinate at 30 is just 1/2. Conversely, your cosine at 30 degrees, that's your x-coordinate. That's the distance across. That guy there is the square root of 3 over 2. If we were going to do the tangent of 30 degrees, you're going to do your y divided by x, which is just a good old-fashioned keep, change, flip. Your 2's would go away, and you have 1 divided by the square root of 3, which works out to be the square root of 3 over 3. So that is what you were doing for your warm-up in the 1.3 part 1 discovering cofunctions notes. Since we're starting a new note packet today, it is worth me saying that what goes on this screen does go in your notes. So if I write it, you need to write it. We're going to do an extra good job today bedazzling some of our notes. If I write something down and you don't understand what I wrote, feel free to ask. Happy to help you along. Anybody want to talk me through 45 degrees? Looks like you guys did a good job.
Sure.
Oh, go ahead, Matt.
2 square root of 2 is the sine.
Yes.
Same thing for the cosine.
Yep.
And we change flip for the tangent.
Yep.
It's 2 square root of 2 times 2 over 2 square root of 2. And that is 2 square root of 2 over 2 square root of 2, which is 1.
Yeah. It is 1. Good job. Alrighty. Anybody want to help me with 60 degrees? Go ahead, Michael.
Square root of 3 over 3 for sine.
Good job.
1/2 for cosine.
Good job.
Square root of 3 for tangent.
Yeah, and the square root of 3 for tangent. Good job. Okay. So I, like you, am not the biggest fan of memorizing. So I wanted to kind of take a moment to observe some key traits. And also allow me to introduce the lesson a little bit for today. Did you notice that the topic for today's lesson is cofunctions? And I think a lot of you would be able to quickly recognize that we have a couple of cofunctions just chilling on that chart. For instance, we have sine, and then we have cosine. You have that prefix CO. I'm quite sure it's been bothering more than one of you that there's this like thing that's hanging out on so many of our functions, right? Like we had tangent and then we had cotangent. You had secant and then you have cosecant. But I've never talked about why that is. Like I've never talked about what that CO is doing there. So today is the day we talk about that. You figure out like what the relationship is when all of a sudden I take my root word and I slap a CO in front of it. What I first need you to kind of take a look at between sine and cosine, so particularly focusing on these 2 columns, is that there's some similar values kind of matching up a little bit. So I'm going to go ahead and highlight those. If you could do the same, that'd be great. For instance, I can observe that the sine of 30 is the same as the cosine of 60. Conversely, I can observe that the sine of 60 is the same as the cosine of 30. And last but not least, if I go straight across at the 45s, those are big arrows, by the way, we got the sine of 45 being the same as the cosine of 45. So even if you just look between those, they're the exact same values in those two columns, just in a different order. So that's sort of planting the seed for what that relationship could be. All right, and then prefix co. I mean, this is a very subjective question. Does anybody know what that means, though? Prefix co.
Together.
Here together. Professor Hollenbeck, what do you say?
Okay.
Yeah, I always so think with. For sure. Any of that works. So they're sort of functions that work with each other. And the mission in today's lesson is to establish how exactly that happens. Okay, this is where you need your calculator. So if you haven't yet done so, can you do me a favor? Bust out your calculator. And then you're going to want to make sure it's in degree mode. So you're going to press the mode button on your calculator. And then we'll start working on our activity for today. And while you're working through your calculator, getting your calculator out, putting it in degree mode, I'm gonna walk around and help you with that a little bit. We're also gonna multitask and do a little bit of vocabulary. So now that the calculators are looking good, everybody's in degree mode, let's just do some quick vocab. Does anybody know complementary two angles that add up to what? Anybody know?
180.
Oh, that's supplementary, so close.
90.
90. 360 is like the whole rotation, the whole revolution. Yeah. Okay, wait. It gets better. Remember that in this class, 90 degrees is the same as pi over 2. So we have some versions of that. So for instance, things that add up to 90 quite commonly would be like 30 degrees and 60 degrees, you know. If you did 30 plus 60, you'd get 90. That makes 30 and 60 complementary. Or, you know, you could do 45 and 45. Those would be complementary angles because if you put them together, they make 90. You know, you could do like 80 and 10. You know, 80 and 10 make 90. So that would be another, for instance, of complementary angles. Okay, but I'm going to add one more. I'm going to go outside the box. Just because we also have angles in radian measure. So, for instance, if I do this one, remember that that's the same as doing pi over 6 plus pi over 3. Pi over 6 plus pi over 3 would give you pi over 2. So, in radian measures, they would be angles that add to pi over 2. So we could have complementary angles appearing in degree or radian measure. Okay, cofunctions also not too bad. To find the cofunctions, some books hyphenate this, some books don't. I've seen it both ways. To find the cofunction of a trig function, all we're going to do is identify the root word attached to the prefix co. That cofunction and the original function come together to make our cofunction. So in my last class, we did talk a little bit about root words. I know, like, who knew that the second floor would be just like trickling on down to the first floor here? But like, you know, if you look at the front of the room there, the first one that caught my eye was the word expectations. Expectations has a root word, right? Anybody know the root word of expectations? Do you know it? Expectations, the root word? Expect, yeah. It's just kind of what I expect of you, right? So my expectations are the thing that we can come to expect of each other, right? So expect is the root word in the word expectations. Well, if you wanted to identify the cofunction for cosine, for instance, you just take off the co. So the cofunction for cosine is just sine. So there's this relationship that we're going to explore today between cosine and sine. Or, we talked about cosecant last week. Well, cosecant, if I just take off co, I have secant. And last but not least, we can have a relationship between cotangent and its cofunction. So if I take co off of the word cotangent, I would just have tangent. And so now that everybody has their calculators in degree mode, we're going to go ahead and type a few things in. So we're now exploring the idea of this relationship that there's, this relationship between like sine and cosine, tangent and cotangent. We're going to use our calculators to figure that out. Okay, first off, let's see if you're all bringing this together. 30 degrees and 60 degrees, when they're combined, they're known as what? It begins with a CO. Complementary, very good. So many COs today, you're right. Very good. Okay, now in your calculator, I know a lot of us know what the sine of 30 is already, but we're going to do the decimals just for fun. So the sine of 30 degrees. Anybody want to key that in and give me the number? Go ahead, Roman. Oh, wow. Nice job, guys. In unison, yeah. 0.5. All right, cosine of 60. 0.5. Did you see what happened there? We had sine. Oops, I meant to grab the highlighter there, sorry. We had sine and cosine. And then our angles, 30 and 60, added to 90. So what was true about our answer to number 2, part A and B? They complement, but more than that, they're the same, yeah. So I don't need a fancy answer. They're the same exact number. We got 0.5 out both times. Okay, now I wanted to play around with the idea in reverse. So not doing 30 and 60, but doing 60 and 30. So 60 and 30, they're still what type of angle? Yeah, I hear it all around the room. Nice job. Good, Roman. Thank you. Complimentary. Okay, so on to question 5. So in your calculator, you would be typing in the sine of 60 and then the cosine of 30. And I just wanted the decimal approximation. If you wanted to go out to like 1 or 2 decimal places, it's up to you. You want to type those in real quick? All right, friends, what'd you get? Yeah, that sounds good. It's like 0.866, 0.87. That is the square root of 3 over 2, for sure. Okay, but what do you observe about those two answers? They're the same. Very good. All right, question number 7. 45 degrees and 45 degrees, when combined, are known of what type of angles? This is not a trick question. It's supposed to be easy. Complementary. Now, we're not talking like, hey, 45, I like your eyes. Hey, 45, I like your shoes. No, they add up to 90. Get it? That's a bad math joke. Nobody laughed. Come on.
Okay, Lucas.
Thanks, Lucas.
Yeah. Cackle. Charlie, not cackle, like giggle.
All right, so now you're throwing in your calculator sine 45 and cosine of 45 as decimals. We actually use these decimal values in section 1.5 when we go to graph our sinusoids. So I'm having you just kind of look at those numbers for a second. They're a little weird looking. They are irrational. All righty. So what is our sine of 45? Yeah. I had 0.71. That is our square root of 2 over 2. What'd you get for cosine? Same thing. So for question number 9, what was true about your answers to part A and B in number 8. Scarlett. They're the same, yeah. All right, wait. Okay, now you get to play on your calculator for a second. I need to be peppered with complimentary angles. Not peppered with compliments. Just, I mean, that's nice too. That's very nice of you to do. Like Mrs. Lucas, your hair looks great today. Okay, awesome.
Looks amazing.
You get an A. All right. No, I wanted just some complimentary angles. So, anybody want to throw some weird numbers that add to 90 at me?
63 and 27.
63 and 27. Okay.
Okay.
So we're going to do in number 10, before we actually write the sentence that goes there, we're going to do the sine of 63 degrees. And I'd like you to compare it to the cosine of 27 degrees. Roman.
They're equal.
They are equal. What is the funky decimal associated with those, by the way? I'm just curious. Was sine of 63, so I can kind of estimate. Go ahead, Scarlett. 0.89. Yeah, pretty close to 60 and 30, right? So it had to be close to 0.866. Yeah, 0.89 is equal to 0.89. And we could reverse that. You could do the sine of 27 and the cosine of 63. We'd probably get something close to like 0.5, but it works. All right, so maybe now you could confidently answer number 10. It says, based on your observations, what can you say about the cofunctions of complementary angles, angles that add to 90? What's true? Question number 10. We're going to try to write a sentence without using any pronouns. So no he, she, it, we, you, they. You think you got something there, Eric? No? Go ahead, Roman. Let's hear it.
90 minus the first one equals the second one. I don't know how to word that properly.
So you were saying 90 minus the first one. So what you're
90
talking about
minus
first is
sin
just
minus the sin angle equals
theta.
the cosine. Yeah, yes, theta equals the second one, which is the second theta. I don't know how to word that.
So what you just told me is theta and 90 minus theta. So those are called complementary angles.
I know I'm on the right track.
So, and then when you said you specifically compared sine and cosine, right? So
Yes.
those were what we called cofunctions.
Yes.
So it could apply to any cofunction.
Yes.
So we would say cofunctions of complementary angles are equal. Yeah,
Yeah, I was on the right track.
for sure. Definitely agree with that. So cofunctions of complementary angles are equal. That is the point of today's lesson. Okay, now let's really make this confusing and give you some weird notation in a chart. Okay, so back to what our friend Roman was just talking about. The first weird thing you're going to notice in this chart, and again, this is problem number 2 on, some copies of these charts you're going to save throughout our study of these together. I think the thing that throws kids is that whole 90 minus theta thing, but I just wanted to address that super quick with you, make that a little easier to look at. So what does this 90 minus theta mean? And you can add this into your notes too. So 90 minus theta in plain old English, what that means is the complement of an angle. Not just any angle. We would say the complement of angle theta. So 90 minus theta can just be read as the complement of theta. So here's kind of why that's a key thing. So what we're saying here is that 90 minus theta, so 90 degrees minus theta, you know, if that's going to be the complement of theta, that just means that if I add theta to it, I should get 90 degrees. And algebraically, that's true. You know, if I go ahead and I simplify the left side of this equal sign, 90 minus theta plus theta, I could drop the parentheses on the first part. So I have 90 degrees minus theta plus theta. Well, these two things undo each other. Of course I get 90 degrees. So this is fancy talk for just being super general. Like, you know, Lucas offered up 23 and 67. We talked about 80 and 10. We talked about 45 and 45. So how does a mathematician state that this works for all complementary angles? Well, they use some variable notation, and that's all this is. So all we're saying is that 90 minus theta is just the complement of theta. So if we extend that then, the sine, sorry, I'm trying to get it all on the screen at the same time. So the sine now of 90 minus theta, well, that's just equal to the cosine of theta. Because if I put 90 minus theta and theta together, those numbers add up to 90. Everybody got all that in their notes? It's a lot to jot down. Okay, I'll do this first column and then I'm going to ask for a little bit of audience participation with that second column there. So the tangent of 90 minus theta, that has to be, it has to be equal to the cotangent of the complement of 90 minus theta, which is just theta. So again, it's just the complementary angle that's on the right there. And then secant of 90 minus theta, that has a cofunction. I could just put the prefix co on it, yeah. So if I take secant and slap co in front of it, I'm at cosecant. Yeah, very good. So that's just cosecant theta. So again, if these two angles on either side add up to 90, the cofunctions will be equivalent. All right. Now a little audience participation to work down that right-hand column. Okay, can anybody tell me cosine of 90 minus theta, what that's equal to?
Sine.
Yes. You okay, Annabelle?
Oh, God.
This is dry, babe. I get.
That was so bad. No, I'm here. I have it all.
I see you have it all.
I do. Wow. Thank you. Thank you for that.
It's not a
I'm
problem.
telling my mom about that. That was good.
No, no judgment on my
I'm here
end.
now. I'm here. I just can't.
It's all good.
No, I'm up. Sorry.
Judgment-free zone. All right. So we have cosine of 90 minus theta. I think somebody said it. What's this equal to? It is the sine of theta. Nice job. So again, as long as these angles add up to 90, those cofunctions will be the same. All right. What's the cotangent of 90 minus theta equal to? Yeah, just take that co right off of there. Yeah, you just add it. You got it. You learned the lesson for today. Congratulations. Yeah, we're just taking the prefix CO on, or we're putting it on, or we're taking it off.
Do we get zeros?
Maybe. Heavens knows I don't want to take those home.
Yeah. For each person gets a full bill.
So the cosecant of 90 minus theta, what is that?
Cosine.
Ooh.
Cosecant.
So you got to take this co off, so it's secant.
Oh.
Secant theta, yeah. So again, the goal is to give you formulas, and what we're going to do right now is now take these formulas and use them, you know, to find something we don't know. So this is now getting into like the algebra part. Okay, so here in example 1, I'll go ahead and let you know I started with an easier problem. Everybody knows the sine of 60 is the square root of 3 over 2, cosine of 60 is a half. I started with numbers on the unit circle because this is an easy problem. But so what I'm saying is everybody knows what the sine of 30 is. It's a half. Like, it's the first y value on the unit circle. You don't need cofunctions to answer this question. So I picked an easy problem to show you how you could use cofunctions to come up with that value. So forgive me if you're like, lady, there's an easier way to do this problem. You're right, and I agree. But I just wanted to use this to teach you how to use cofunctions to your advantage when the numbers are not cool. All right, so what you need to think about is that the sine function has a cofunction. The cofunction for sine is cosine. How did I get that? I slapped a CO in front of it. Next up, I got to look at this 30 degrees, and in my head, I'm thinking, okay, cofunctions of complementary angles are equal. So what is the complement to 30 degrees? Good, Scarlett. It is. And then do you see what they did here? They gave you the answer to the problem right above it. They came out and told you the cosine of 60 is a half. So it's about using the given information and your identity to solve for what you don't know. So courtesy of our property of substitution, they're telling me the cosine of 60 is 1/2. So I can now sub in the value for the cosine of 60. The cosine of 60 is 1/2, and that's the answer to the problem. So it's literally one step worth of work and then the answer. All right, let's try it again. So the cosine of 30. What is the cofunction for cosine? You're right, it is sine, yeah. So just take the CO off of it. Then you have to look at your angle and ask yourself, what's the complement of 30 degrees? Yes.
I was awake.
So notice that the cosine of 30 is going to be the same as the sine of 60. And they give you that number right over here. So we use our property of substitution, and I now know that the sine of 60, according to this first given in the problem, the sine of 60 is just the square root of 3/2. So that is the answer to this problem. So do you see how there's one step before I put the answer down? That's what we're getting at. All right, let's try one more. To get this particular example started, we're going to do parts C and D first because that backs us up quite nicely to yesterday. So I wanted to go ahead and just take a moment to start with part C there at the bottom left. And that problem reads, find the secant of 90 minus theta. So what you see on this chart that we completed a little earlier is that we know what the secant of 90 minus theta is equal to. So as you read through your chart, this chart up here, I'm looking for the secant of 90 minus theta. So in my chart, yes, nice job. The secant of 90 minus theta is equal to the cosecant of theta. Nice job. So that's going to be my first step. I'm just writing down what secant of 90 minus theta is equal to. And then conveniently, I don't know if you see it or not, they actually give this to me in the prompt. They tell me, hey lady, the cosecant of theta is 3. So all I have to do now is substitute the given information into the cosecant of theta. So they're telling me the cosecant of theta is 3. So I'm going to replace this cosecant of theta with what I know about it. They told me it's 3. So the answer to this problem is actually just 3. So you see that there's really only 2 steps for the problem. You have to figure out what it's equal to and then do your substitution. All right, let's try this next one here. This time around, they're asking me what is the cosecant of 90 minus theta. So I just kind of look at my chart. And I actually see it up there. The cosecant of 90 minus theta, if you look it up, you know, again, you'll have to have this memorized at some point. But for now, if you look at the chart that we filled out yesterday, the cosecant of 90 minus theta is equal to the secant of theta, yes. So that's step one. Figure out what the problem is actually equal to. And then step two, what we're going to go ahead and do is use the given information to answer the question. So the secant of theta, if you see right there, they gave me a value for it. They told me, hey, you know, it's 3 root 2 over 4. So the secant of theta gets replaced with 3 root 2 over 4. So that is your answer. Two more and then we're done. Okay, are there any questions about C or D before I go on to the next two? All right, so going backwards, we're now with A and B, and then this lesson is done. We'll get a little bit of practice. Remember, we also have these things called reciprocal functions. So if we really focus our attention on the first part of the problem, really focusing on sine A, I have to decide, step one, which of these two given pieces of information is sine actually related to? And that's a question I'm going to throw out to you guys. I heard it in 2 places. Is that what you said too? Yeah, that's what I thought. Yeah, sine is actually our reciprocal of cosecant. So in this case, this one again is related to cosecant of theta. If you want to find sine, I mean, the shortcut is just to flip cosecant. The way we write that is just by stating that sine, oops, wrong color. Sine is equal to 1 over cosecant. So if we're using this whole idea that we can just substitute what cosecant is equal to in there, I just have to replace what's in this box right here. So the cosecant of theta, once again, was just 3. So 3 is the substitution I made there for cosecant, because those things were equal to each other according to my given information. The other thing you could have done is just flip 3, you know? Remember that 3 has a reciprocal of 1/3. So notice we get the same answer either way. You can either flip your cosecant value to find sine, or you could just divide it into 1. Yes, Annabelle?
Wait, why did we flip it again?
Because sine and cosecant are what we call reciprocal functions. And to identify a reciprocal, you just flip.
Oh.
Do you know what I mean? Like, so the reciprocal of 3/4 is 4/3. The reciprocal of the square root of 2 over 2 would be 2 over the square root of 2, which is 2, or square root of 2. Almost misspoke there.
And like, putting it on the bottom, does it just help us cancel it out?
Yeah.
Okay.
When you flip a fraction, you're dividing it into 1. So there's 2 ways we can represent the flippage. One is just to flip it, the other one's to divide it into 1. And then you're doing keep, change, flip. Yeah.
Okay.
Okay, so for part B then, our last problem of the day, you almost made it. The cosine of theta has a reciprocal trig function listed in our givens. You're all very smart people. By process of elimination, you could probably guess that cosine is then tied to our secant value. In fact, secant and cosine are reciprocal trig functions. So cosine is equal to 1 over our secant. And then we just kind of substitute what we know about the secant of theta into that fraction. And in fact, we did say that the secant of theta is actually 3 root 2 over 4. So in that box right there, I could put 3 root 2 over 4. Because this was in our given, those two things are the same. You can't leave me an answer that looks like that. So as Annabelle and I were just talking, you would do your keep, change your division to multiplication, and flip 4 over, or bleh, flip 3 root 2 over 4 to be 4 over 3 root 2. And then, you just kind of multiply straight across the top, straight across the bottom. You're only ever multiplying by 1. The pain in the bum about this one is that I got to multiply the top and bottom by the square root of 2. Because I can't have a square root on the bottom. So I would multiply straight across the top. I'd have 4 square roots of 2. Straight across the bottom, remember the square root of 2 times the square root of 2 is the square root of 4, and that's 2. So we'd have 3 times 2 on the bottom. 3 times 2 is 6.
I had that, but I erased it this way.
Oh, it's weird looking. That's a weird looking number. It is just a number though.
I did it just by
Just flipping it right out of the gate?
yeah.
Perfect. That is the other way of doing it. You got it. The last thing you would want to do though is reduce 4/6. Big kids aren't going to leave that in an answer. 4/6 is actually 2/3. So you have 2 root 2 over 3 as the answer to our last example of the day.